Hello everybody. So in this video we are going to talk about modulus and some of the things related to it, like equations and its inequalities. So let's start with it. So modulus or absolute value of a number or a function is the same thing, and that is represented like this. So f of x is equal to modulus of x. If you write, it means that is x if x is greater than or equal to 0, and that is minus x if x is less than 0. This equal to thing you can take over here as well, it's your choice, right? So what does it mean? If you want to find modulus of a positive number, it's the same number. If you want to find the modulus of a positive number, it's the same number, right? And if you want to find modulus of a negative number, you have to put an extra negative sign. You see, the number is minus 8, you have to put an extra negative sign. So that will also be 8. If you want to find modulus of a negative number, that is the same number, and you have to put an extra negative sign. So that is 2 by 3 as well. I hope that is clear. And modulus of 0 is equal to 0 itself. There is no confusion in this thing, right? Now you might ask why this thing is working, why you're putting an extra negative sign. Because I'll use the number line for this to explain this logic. Suppose this is 0, this is 2 by 3 and suppose this is minus 2 by 3. Suppose I want to find modulus or absolute value of 2 by 3. So absolute value of a number is the distance of it from 0. The distance of it from 0. So distance of 2 by 3 from 0 is 2 by 3 only. Correct? So therefore modulus of 2 by 3 is 2 by 3 only. And if you want to find modulus of minus 2 by 3, what is that? It is also the distance of minus 2 by 3 from 0 on the number line. The distance of minus 2 by 3 from 0 on the number line. You see, that will also be 2 by 3. You see, if the number is negative, that does not make this distance negative. Distance can never be negative. So therefore, that is 2 by 3 only. So therefore, modulus of both positive as well as negative numbers is positive only every time. Sometimes it is also called, therefore it is called absolute value. It means you're just taking the value irrespective of the sign. I hope it is clear. So that's all about the basics of modulus over here. Now sometimes they can give you simple equations on modulus. For example, if I give you this thing, suppose 2x plus 1 is equal to suppose 3, right? So you have to find the value of x. Now you see over here, modulus of something is equal to 3. So can't we say that over here 2x plus 1 is equal to 3 and 2x plus 1 is also equal to minus 3. Why? Because modulus of both 3 and minus 3 is equal to 3. We have studied today itself. So therefore from here you can say x is equal to 1. That is correct. And from here you can say x is equal to minus 2. So both the answers are correct over here. X is equal to 1 and x is equal to minus 2. I hope that is clear. Now sometimes they can give you a simple question like this. For example, modulus of 2x plus 1 is equal to minus 5. Can you solve it? Right? So you don't need to even use your logic over here. You see, modulus of anything can never be negative. So therefore you will not have any solution over here. You don't have to think that much. Modulus of anything can never be negative. So it will have no solution at all. No problem in that. I hope that is clear. Right? Okay. Now suppose let's try to solve this thing. Now over here, you see, it's not a single expression over here. You have got two moduluses over here. So you have to break it into, intervals basically. Then only you can think whether this will come out with a positive sign or negative sign, each of these over here. Now basically, what is the 0 of this polynomial? So you can say if you take 2a plus 7 is equal to 0, so you will say from here a is equal to minus 3.5 over here, or minus 7 by 2 basically, and the 0 of this polynomial is inside the modulus, so a is equal to 0.5. So these are basically the critical points over here. Critical points means the points of sign change in this context we are talking about. So basically you can just show them on the number line for you to understand. So you see that is minus 3.5, minus 3.5 and 0.5, correct? So we have to break them into categories. So suppose the first case I'm talking about over here, when I take a less than minus 3.5, a less than minus 3.5 in this class interval, right? So when you take a less than minus 3.5, 2a plus 7 will be negative and 2a minus 1 will also be negative. So they will open up with a negative sign, right? So minus 2a plus 7 and minus 2a minus 1, correct? And that is equal to 8. You can solve this, guys. This is minus 2a minus 2a. That is what? Minus 4a. And you see this is minus 7 plus 1. So minus 7 plus 1 is what? Minus 6. Minus 7 plus 1 is minus 6. Take it on the other hand side. That is 14. So you see from here a is coming out to be minus 7 by 2, minus 7 by 2. So that is minus 3.5 only. Now basically what you have to understand over here, you don't have to think that much. This is not an integer. You can't take it. Simple. This is not an integer. And also you see this is not a solution as well. Why this is not a solution? Because over here the condition is a is less than minus 3.5 and you are getting a is equal to minus 3.5, right? And another way is to check, to put in the equation and check. If you will put in the equation and check, is it working? If you put in the, the best thing is to put in the equation and check. So this is minus 3. Let me check if it is correct. So minus 4a minus 7 plus 1 is minus 6, minus 7 by 2. Actually this is correct. You see, because minus 3.5 if you put over here, you see this is going to be 0. And minus 3.5 if you put over here, minus 3.5 into 2 is minus 7. Minus 7 minus 1 is minus 8. Its modulus is 8. So although this solution is correct, you see this solution is working in the actual equation. But over here, because a is an integer, so you will neglect this solution. You have to neglect this solution. You can again check minus 7 by 2 over here. If you will put over here, you see that will be 0, and minus 7 by 2 it will be a solution, but we can't take it because it's given over here that a is an integer. That is the first thing. Now the second category which we can take over here, can I take a greater than equal to minus 3.5 and less than 0.5 over here, suppose? Yes or no? So when I will do that, this will open up positive and this will open up negative. So you will get 2a plus 7 over here, but this will be minus 2a minus 7, and that is equal to 8. If you simplify, what you are getting? 2a minus 2a is 0 only, and this is 7 plus 1. So that is coming 8 is equal to 8. What does it mean? This is a true statement. This is a true statement. It means that in this class interval, every value of a is a solution. In this class interval, every value is a solution. Every value of a, if you will take, is a solution. But we have to take only integer values. So just for you to understand, you can draw the number line over here and understand that this is minus 3.5. And then before that, you've got minus 3, minus 2, minus 1, 0, and 0.5 somewhere over here. So you see 0.5, 0, minus 1, minus 2, minus 3, minus 3.5. So between these two, between minus 3.5 and 0.5, what are the integers? Minus 3, minus 2, minus 1, 0. So what can you say? A is equal to -3, -2, -1 and -0 are the integer solutions. Over here. Now what is the third case which we can take? The third case which we can take over here is A is greater than or equal to 0.5. See this, right? So in that case, all of them will open out with positive sign, right? So that is 2a minus 1 and that is equal to 8. You can solve it. This is basically 4a and this is 6. 8 minus 6 is 2. So basically a is coming out to be half, right? Or you can say 0.5. A is coming out to be half or 0.5. So you see, this is the solution over here, because you can obviously check it over there as well and it will be the solution. You can check it because 0.5 will make this 0, right? It is the 0 of this polynomial. And if you put 0.5 over here, 0.5 into 2 is 1. 7 plus 1 is 8. Modulus of 8 is 8. So it is a solution for sure, but we will not consider it because they are saying that A is an integer solution. So this is a solution, but we are not considering it as per the question. So you can say as per the question, only 4 integer solutions are there. As per this question, only 4 integer solutions are there. Now, I hope you understand that why I have put this question. Many a times it comes up in many competitive examinations when you have to open up modulus using, cases basically, using different intervals to open up modulus. I hope this question is clear. Okay, it's for the same thing. Now, sometimes you get modulus inequalities as well, and that's a small thing to understand. For example, just understand that if you have got modulus of x less than equal to 3, just see on the number line, you will realize that. Suppose this is -3 and 3. So if modulus of x is less than or equal to 3, do you realize that x will be between these two? Just think that. Because if x is greater than 3, its modulus will not be less than 3. If it is less than -3, suppose -4, its modulus will be not less than 3 in that case as well. So if that is the situation, can I not say that x is greater than or equal to -3 and less than or equal to 3? So this is the modulus inequality which you have to understand. It means that if modulus of x is less than or equal to a is a positive number. So over here you can say x is greater than equal to -a and less than or equal to a. This is the first thing, right? Now second thing also you can understand using examples only. That's very simple to understand. For example, it is written modulus of x is greater than or equal to 2. You draw the number line over here, -2 and 2. Now don't you think if x is greater than 2, then only its modulus is greater than 2? And if it is less than -2, then only its modulus will be greater than 2. So can't we say that the solution of it will be what? X belongs to -infinity to -2 closed interval and union 2 to infinity. Do you understand that? That's it. So if it is modulus of x greater than or equal to a, it implies that x is greater than or equal to a or x is less than equal to -a. That you have to understand. I hope that is clear. You see, these has to be positive numbers only. Why? Because for example, if somebody gives you modulus of x is less than equal to -5, is it possible? No solution. Because modulus can never be negative, so you don't have to even think on it, right? Modulus can never be negative. I hope that's clear. I hope that is clear, right? Fine. So that is the situation over here. Let's do a question on it. For example, they are saying that, you see, modulus of x minus 220 is less than 5. Is less than 5. This is a simple modulus inequality. If you know the property, you don't have to think that much over here. You don't have to think that much. So whatever is there inside the modulus, see, we have studied today itself that if modulus of x is less than a, we can say that x is in between minus a and a, isn't it, guys? So whatever is there inside the modulus, can't we say that modulus of x minus 2020, it is greater than minus 5 and less than 5? Correct, that's direct. So from here, modulus of x is greater than, it will go over there, you'll get 2015, and it is less than, it will go over there, 2025. That's it. So you see, modulus of x is in between minus 2015 and 2025. Modulus of x is in between 2015 and 2025. So, and that is an integer. You have to find integer solutions. So modulus of x can be what? You see, it can be 2016, 2017, and so on up till what? And so on up till 2024. How many values are there? You can just calculate it. You see, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's 9. 16, 17, 18, 19, 20, 21, 22, 23, 24. That's 9. Right? You can calculate that. But that is modulus of x. So x will have how many values, guys? Will it not be plus minus 2016? Will it not be plus minus 2017 and so on? Up till what? Plus minus 2024. Will it not be 18 values, guys? Tell me. So 18 integer solutions it will have. You can again check it. You see 16, 17, 18, 19, 20, 21, 22, 23, 24. I hope that's clear. So that's a simple modulus equation. You see 18 integral solutions are there. Simple modulus inequality if you know the properties. But the best thing which I was explaining over here, the most important actually, this was a simple question, although this is the most important thing. To open up, you know, intervals, to open up like this, and that can come in an inequality as well, basically. That can come up in an inequality as well. So I hope these things are clear. This thing is the most important thing which I was explaining. You must know that, and you have to properly revise it. That's very important from any competitive examination point of view. That's all I was explaining on the basis of modulus and modulus inequality. I was not going into graphs and all that, okay? Although graph and all that is also there. I'll make a separate video on, you know, how to draw graphs and all that. That's all I needed to discuss over here, guys, on the Infinity Learn Class 9 and 10 YouTube channel. Don't forget to subscribe to the Infinity Learn Class 9 and 10 YouTube channel, and don't forget to subscribe to the Telegram channel as well, because whatever is discussed in a live session, you can get the PDF of those sessions as well. Bye-bye, guys. Take care, everybody.